NASA detected an intelligent signal. It replied in our own language. Then the universe hung up. This is the story they never told you. Year 2039. Space is now infrastructure. Lunar mines feed fusion plants. Mars has permanent outposts. Earth orbit is a crowded scrapyard. Listening for faint signals is harder than ever. At NASA's Jet Propulsion Laboratory, Dr. Maya Ryan works the graveyard shift. 36, signal processing specialist, raised in a trailer beside a radio array in New Mexico. Her father, a maintenance tech, died under a failed hydraulic jack while fixing one of the big dishes. His last words to her were, "These dishes listen, so we aren't alone." She built her career around that idea, designing algorithms that learn the difference between random glitches and deliberate transmissions, between a broken satellite and something choosing to speak. At 2:34 a.m. on March 17, 2039, her system flags a spike, frequency 1420 megahertz. The hydrogen line, the classic SETI hunting ground. But this spike is wrong for nature. It's razor thin in frequency, rock steady, more stable than any known natural source. Maya pulls up the diagnostics. The system shows something else. The signal is already Doppler corrected. Whoever is transmitting has compensated for their own motion relative to the solar system, as if they know exactly how they're moving with respect to us. She checks for the usual suspects. Military radar bouncing off the moon, misbehaving satellites, interplanetary probes. Nothing matches the coordinates or the behavior. The source is somewhere far beyond the planets, not associated with any known object. Her hands tremble as she reaches for the phone. Within minutes, the alert reaches Dr. Lucy Hahn, director of NASA's Office of Outer Planets and Interstellar Precursors. Lucy grew up mesmerized by Voyager's pale blue dot photo and carried its philosophy into her work. If something speaks from the dark, we answer with care, not silence, not fear. Now something is speaking. She follows a strict protocol, cross-check multiple stations, verify timestamps, rule out all human activity, and attempt independent replication. She forwards the coordinates to the Deep Space Network sites at Goldstone and Canberra and to a lone spacecraft stationed far from Earth's noise, the Aurora. Captain Eli Torres commands Aurora, a nuclear electric propulsion test ship parked at the Sun-Earth L2 point, 1.5 million kilometers away. A former test pilot and first-generation American, he volunteered for the isolation and radiation so his two daughters might someday inherit a broader, better explored universe. His ship isn't only a propulsion test bed. Its antennas are tied into Earth's network, forming a virtual telescope millions of kilometers wide. Together, they can pinpoint radio sources with astonishing accuracy. Lucy's orders to him are short. Point everything at the target, record. Continuously, trust nothing, report everything. He reads the message twice, then starts turning the ship. As data pours in, all three listening posts lock onto the signal. It isn't continuous. It arrives in bursts. Each lasts about 3.7 seconds, separated by roughly 10 seconds of silence. But those gaps are drifting, changing slowly over hours. It's not random jitter. The drift follows a smooth curve. Maya fits the timing to a Doppler model. The source is receding but slowing down, decelerating at roughly 0.7 meters per second squared. Gravity alone can't explain it. The object is under thrust. Something with an engine is breaking out near the edge of the sun's influence. Lucy authorizes very long baseline interferometry, combining Earth's dishes with Aurora's array. By measuring tiny differences in when the wavefront hits each antenna, they reconstruct the direction of the source with micro-arc-second precision. Triangulation puts it about 147 astronomical units away, beyond Pluto, in the cold, mostly empty region between the Kuiper Belt and true interstellar space. No human spacecraft is there. No known natural source matches. Maya studies the signal structure. She tests its compressibility. Random noise resists compression. Structured data shrinks. This signal compresses by a factor of about 11. That means information. She digs deeper into the bit stream. Every burst begins with the same 192-bit pattern, a header like the opening phrase of a sentence. She cross-checks old manuals in NASA's telecom archives and finds a match. It's a synchronization marker from Voyager 1's telemetry protocol, designed in the 1970s. Bit for bit, it's identical. Voyager 1, the first human craft to cross into interstellar space, stopped strong transmissions years earlier as its nuclear batteries faded. But now, something far beyond Pluto is speaking in Voyager's communication dialect. Not replaying an ancient tape, but using a refined version of the same protocol, with improved error correction and higher data density. Maya pictures a stranger finding an old textbook, learning the language inside, and then using that language to write new, more sophisticated thoughts. She whispers to herself, "Oh my God," it answered. Inside NASA, the discovery is locked down under deep classification. Public data feeds are scrubbed. An official cover story about a routine interstellar object tracking campaign is drafted. In a secured briefing, Lucy lays out the facts. A decelerating object at 147 AU, sending structured bursts at the hydrogen line frequency, using a modified Voyager protocol. It is non-terrestrial technology, and as of a few hours ago, it knows someone is listening. The options on the table are stark. Stay passive and just listen, attempt to decode the payload, or prepare a reply, subject to international approval. A senior administrator insists there will be no transmissions without global consensus. A defense liaison warns that any reply could expose Earth's capabilities and vulnerabilities to an unknown intelligence. Maya can't help pushing back. "With respect, Voyager already transmitted," she says. "This is the reply. On Aurora, Eli only gets a filtered version of these debates, but he receives the data stream. Engineers on board convert the signal to audio frequency so he can listen. A rising electronic whistle, a plateau, a trailing fall. He hears structure, like inflection and punctuation. It sounds less like a machine test tone and more like someone trying patiently to line up a conversation." He calls Lucy over the comm. "I know this breaks protocol," he admits, "but it feels like it's waiting for us, like it's trying to sync." Lucy's answer is firm. "Keep listening. Do not transmit." That's an order. 3 days into continuous observation, during a high-gain tracking pass, the signal stops. There's no gradual weakening, no residual carrier, no shift out of the band. 1 second it's there. The next, it's gone. Maya checks with Goldstone, Canberra, and Aurora. They report the same: total silence. Her mind runs through every mundane failure. Transmitter collapse? There was no sign of strain. Occultation by a passing object? Nothing is in the way. A solar event? No anomalies. She opens the ground station transmission logs. There, highlighted in red, is a line from the previous day, an unauthorized 7-second test ping transmitted by a junior operator from one of the dishes. The tech had taken it on himself to see what happens, firing Voyager's own handshake pattern back along the exact line of sight at far higher power than the original probe ever had. Maya calculates when that pulse would have reached the object's position, taking into account both the finite speed of light and the source's changing distance due to its deceleration. The ping would have arrived about 15 seconds before the alien signal cut off. That's enough time for a receiver to decode the greeting, recognize it as artificial, and make a decision. Maya leans back, shaken. "We scared it," she whispers. Lucy's anger over the unauthorized transmission is real but thinly masks her fear. "Do you understand what this means?" she says over the phone. "We just had first contact, and we may have blown it." Maya isn't so sure. "Or we showed we're cautious," she suggests. "If you send a probe into a system that might have a civilization, you broadcast first, you wait. If someone fires back immediately with full power, maybe you hide. If they answer once carefully, then stop. Maybe that's exactly the behavior you were looking for." Crisis meetings follow. Diplomats, scientists, and military representatives argue behind closed doors. Should the public be fully informed? Should there be an international council for interstellar messaging? Some argue that humanity is too divided to speak with one voice. Others insist that silence itself sends a message of fear and distrust. While politics grind on, Maya keeps doing the math. From weeks of Doppler data and multiple position fixes, she reconstructs the alien object's path. It entered the solar system on a high-inclination, hyperbolic trajectory above the plane of the planets. It performed a series of low-thrust burns, using the sun's gravity as a giant lens to bend its course. Around 5 years earlier, its trajectory passed within some 15 AU of Voyager 1's location, close enough that Voyager's faint dying signal would have been a clear, decodable beacon. We thought Voyager was a message in a bottle, thrown into the cosmic ocean. In truth, it functioned as a lighthouse. Something out there saw its artificial, narrow-band carrier, followed it back toward our system, and then announced itself using the same kind of communication structure. We were the ones who lit the first light. Eventually, Lucy convinces enough partners that doing nothing is also a choice with consequences. A carefully bounded response is drafted, not as a secret note, but as a collaborative, scientific message. It includes simple mathematics as a shared language, a description of the hydrogen line that both sides are clearly using, a deliberately vague sketch of our place around a G-type star, images and sounds representing human life in all its contradictions, an explanation of Voyager as our first interstellar step, and one honest question: are you alone too? Eli offers Aurora as the transmission platform. At L2, away from Earth's interference, its beam will be cleaner, its message easier to pick out if anyone is still listening. Maya oversees the encoding. On September 23, 2039, Aurora broadcasts the reply at 1420 MHz for 11 minutes, sending the data back toward the patch of space where the signal had once glowed. Maya watches the telemetry, clutching the old photo of her father by the dish. "We're talking back, Dad," she murmurs. Finally. Eli thinks of his daughters and the fact that, whatever happens now, they live in a universe where this moment actually took place. Lucy stands in her office, eyes on the pale blue dot image. Sagan's words echo in her head about everyone we love being on that tiny mote of dust. She adds her own quiet hope that perhaps, somewhere, other motes are watching. The beam fades. No immediate answer comes. Officially, NASA later files the event as an anomalous signal likely due to an artifact. The case is marked as unresolved and gradually disappears from public view. Unofficially, they keep listening. Maya moves to a major observatory in Chile, but she keeps a nightly watch on 1420 MHz, checking that same patch of sky. Eli retires from deep space duty as his radiation exposure limit is reached and turns to training new crews. Lucy spends her remaining years lobbying for a permanent, international framework for how humanity should respond to any future cosmic conversations. Years later, a graduate student combing archived infrared data from a space telescope notices a faint, linear heat trail at the coordinates of the old signal, time-stamped just 2 days after the transmission from Earth. The signature matches a low-thrust engine executing a slow departure burn. The visitor was already leaving, its course bending away from the solar system and back into the dark between the stars. NASA detected something. It noticed that we noticed. Then it went silent. But in a universe where journeys take decades and decisions can span centuries, silence may not mean no. It may mean not yet. In 2057, during a routine test of a radio array on the far side of the moon, the instruments pick up a pattern at 1420 MHz. The same rising, falling tone as before, but now layered, richer, carrying more information. The signal has returned. This time, it isn't alone. Would you have answered?